Hi everyone, today we are going to study chapter 5C, that is numericals based on length formula. We already completed chapter 5A and 5B. In that I give you a detailed explanation on two different types of lenses and image formation by a lens when the object is kept at different positions. Now we are going to do the numericals under this topic, and here we are using only three formulas. The first formula, length formula, that is 1 by f is equal to 1 by v minus 1 by u, and the magnification means when you are taking a photo using your mobile phones, you know how to zoom in and zoom out. That is called magnification. So for finding magnification, we have the formula I by O or V by U. And the power of the lens formula is 1 by F. Now let me explain what is F, V, U and all. F means the focal length of the lens. Okay, F is the focal length, either concave or convex. F is the focal length. V, distance between lens and the image. Okay, V means distance between lens and image. And U is the distance between lens and the object. Okay, lens and object U. And we have I. I means it is the height of the image. Height of the image. And O means height of the object. Okay, so I think it is clear. F, focal length. V, distance between lens and image. U, distance between lens and object. I is the height of the image. U is the height of the object. P is the power. F is the focal length. Now, if you want to do the formula, we cannot simply substitute the values of focal length, distance between image and object. We cannot do it. We have to use some sign conventions. Sign conventions means, here you can see this is a convex lens. I am just placing an object in front of a convex lens. So here this distance, height of the distance, we can take it as O, height of the object. When I place an object in front of the convex lens, you know how to do the image formation. In 5B we done lot of diagrams. We do lot of diagrams on image formation by convex lens. We have to draw a straight line parallel to principal axis. After refraction, it will move through the focus. Three rules are there. So the same way, we have to consider all the distance. Here you can see this is the pole. Middle is pole or optical center. We used to say it as optical center of the lens. All the measurements are taken from the optical center. All measurements taken from the optical center. That means if we want to measure the distance between lens and the object, we should measure in this way, from the optical center to the object. If we want to measure the distance between the lens and the image, from optical center, measure in the forward direction. So first rule you have to keep in mind is, all the measurement should take from the optical center. Okay. Now the second case 2 is, all the measurement in the direction of incident ray are taken positive, opposite are taken negative. I will explain. All the measurement in the direction of incident ray. So how will you draw the incident ray? This is the direction of incident ray. Okay. From the object, the light will travel in a straight line. So in the direction of incident ray are taken positive. That means if I want to measure the distance between lens and the object, that is U. I already told in case 1, first rule, all the measurements are taken from the optical center. So from optical center I have to measure in the opposite direction. According to rule 2, all the measurements are taken in the direction of incident ray. So here you can see incident ray is moving in forward direction and we are supposed to measure the length in the opposite direction. So we will take U as negative. Okay, for a convex lens, we will take U as negative. Why? Because the direction of incident ray is forward, but we are asked to take the measurement always from the optical center in the opposite direction. So both are in opposite direction. So we will take for a convex lens U is negative. Same case for concave lens also. This is our object. This is the optical center. This is the direction of incident ray. Okay, direction of incident ray. But to measure U, distance between object and lens, from the optical center we have to measure it in the backward direction. So incident ray forward and measurement in the backward direction. Both are in the opposite direction. So here also we can take U is negative. Is it clear? So for a convex lens, U is negative. For a concave lens also, U is negative. Next one, focal length. So for the focal length also we will take for a convex lens. We don't want to find the direction and all. It is a concept. Focal length of a convex lens is taken positive and focal length of a concave lens is taken negative. And V, how to calculate V? Focus is constant, magnification and all constant. U, V and all we have to find. V. Here you can see, here is my image. Okay, this is the image in the direction. Image is in the direction of incident ray. This is the incident ray. And we are asked to calculate or measure the distance between object and image. That is also in the same direction. So you can see measurement taken from optical center. From here to image. And direction of incident ray also same. So both arrows, both are same. So we can take, it is positive. So we can take convex lens. V is positive. And here there are two kinds of images. For a convex lens, when we draw the ray diagram, we have drawn 6 diagrams. When the object is at F, at C, between F and C, beyond C, then at infinity, between F and P. In all that, the first 5 diagrams, we got a real image. Real image means we got it on the opposite side. So if the object is on the opposite side, then we can take it as V is real. Then this V is positive. And in the last diagram, when the object is between F and O, I think you remember all that things. You just revise first chapter 5b. Then only you will get an idea what I am explaining right now. Okay. So real images, all the real images will be formed on the opposite side. That is why the direction and measurement both in the same direction, real images are positive. And virtual image means you studied in the last diagram, when the object is between F and P, we will get an enlarged erect image on the same side when it produced backward. So this is a virtual image. So when the image is getting on the same side, on the first side where we are keeping the object, that kind of images are called virtual images. Is it clear? So here you can see V, the distance between optical center and the image, or distance between lens and the image. If it is a real image means opposite side is taken positive. When it is a virtual image, you can see virtual image will be formed on the same side. So measurement is taken from the optical center towards left. That means opposite to the direction of incident ray. It is taken negative. Okay, so here you can see V is positive when it is a real image. V is negative when it is a virtual image. And for a concave lens, you know, for a concave lens, there is only one image formation. We always get the image on the same side. Okay, for a concave lens, we have only one diagram. In that you can see wherever we keep the object, we will get the image between lens and the object. That is on the same side. So there is no any confusion. For a concave lens, V is always negative. For a convex lens, if it is real image, positive, virtual image, negative. Next is magnification. How much it gets magnified. So that also we cannot measure from the diagram. We have to study it. If it is a real image, it is negative. For a real images, it is negative. And for a virtual image, we will take it as positive. In case of concave lens always form virtual image. There is no option for real image. Concave lens always form virtual image. So directly we can write magnification is positive. Virtual, it is erect. That is why we will take positive. So there is another case, that is, this is the principal axis. All the measurement above the principal axis is taken positive. All the measurement below the principal axis is taken negative. So from this you can, without by hearting, we will get magnification. If it is a real image, real images will be always inverted. So it is below the principal axis. So it is taken negative, magnification. That is, image will be either magnified or diminished. Okay, so real image is below the principal axis. That is why taken negative. And virtual images will be always erect, on the same side, erect. That means above the principal axis. So we can take positive. So for a convex lens, all the conditions, two conditions are possible. It can be either real or virtual. But for a concave lens, it only forms virtual image. So here M is real if it is negative, and virtual, then we have to take positive. And for the magnification concave, it is only positive because it forms only a virtual image. Then length of the object, as I told, I by O. I is the length of the image, O is the length of the object. Generally, we place the object here. It will be always above the principal axis. So object is always taken positive. Okay. In case of convex and concave, the object will keep on the principal axis. That is, measurement above the principal axis. So height of the object is always taken positive. Then length of the image. In case of convex lens, image formation. In convex lens, sometimes we will get inverted image, that is real image. Sometimes we will get erect image, that is virtual image. So if it is a real image, so what will happen? It is below the principal axis. So length of the image, if it is real, it is taken negative, and virtual, it is above the principal axis, it is taken positive. For case of a concave lens, object is positive, but image we will have positive because concave lens always form an erect image above the principal axis. So for a concave lens, height of the object and height of the image both are positive. So I think you will be a little bit confused while seeing all the rules together, but it will be clear, no need of any sort of tension. It will be clear once we start doing the numericals. In the numericals, this is purely for numerical section, no need of studying anything from the theory portion. It is purely meant for numericals. And from that, in this chapter, the last portion is power of lens. This last portion is being omitted due to our pandemic coronavirus. So that last portion, power, we don't want to study, but we just want to study the formula. Don't want to do any problems related to power. So next we are going to deal with the first problem. So once we start the problem, all the confusions will get clear. Don't worry. Okay. So we are going to deal with the first numerical. At what position of a candle of length 3 cm be placed in front of a convex lens so that its image of length 6 cm is obtained on a screen placed at a distance 30 centimeter behind the lens. So this is our diagram. We have a convex lens. It is clearly mentioned. The object, here they are mentioning the object as a candle. The length of the candle is given 3 centimeter, and the image of this candle is obtained on the screen. When we place the screen behind the mirror, we will get an inverted image. It is in the text, in the question it is clear, behind the mirror. Whenever we get an image behind the mirror, that means it will be an inverted image. Inverted image means it is a real image. Okay, this all should be understood. So at a distance 30 centimeter and the height of the image is given 6 centimeter. So from here we had to find u, that is distance between lens and the object, and this distance is the height of the object. O 3 centimeter, I 6 centimeter. Distance between the lens and the image is given by V, that is 30 centimeter. And keep in mind, all the measurements above the principal axis positive, measurements below the principal axis negative, and from the all the measurements towards the left side of the lens, this side, all the measurements will be taken negative. On the opposite side positive. So u is in this side. In front of the lens negative. So u is negative. V we get on the opposite side. So it is positive. So keep in mind, above positive, below negative. Left hand side negative, right hand side positive. That only you just want to keep in mind. So now we are going to find O is given 3 centimeter, I is 6 centimeter, V is 30 centimeter. Question is to find U and F, distance between object and the lens, and focal length of the given lens. So first we can find U. For that we have the formula magnification. M is equal to I by O equals V by U. So we don't want this magnification. I am going to take this to equate this two formula. I by U is equal to V by U. Here, after writing the formula, keep in mind you have to put the sign. That is sign convention. If this step is wrong, if you got the correct answer, you will get 0 mark. Because this is the important step. Without proper sign, if you get the final answer, the answer will not be considered. So I means image. Image is below the principal axis, taken negative. O, object, height of the image, object, above the principal axis, taken positive. Okay. Now V by U. V means this distance from the lens towards, that is RHS, right hand side. Right hand side is taken positive. So V is positive. U is in this side, in front of the lens. In front of the lens, negative. So use negative. Now we substitute. We have the values 6 by 3. I is 6, O is 3, V is 30, and you have to find U. Just a cross multiply. 6 by 3 is negative 2. Negative 6 by 3 is negative 2. 30 by minus U. Just cross multiply. Negative U is equal to 30 by negative 2, that is negative 15. Negative U is negative 15. So U is equal to 15 centimeter. So we got this length as 15 centimeter. Second sub question is to calculate the focal length. We have the length formula focal length. 1 by F is equal to 1 by V minus 1 by U. Again, put the sign properly. Focus of a convex lens, that is fixed. Focus of a convex lens is positive. So write here positive. And V, RHS side, so positive. U again in front, LHS side negative. So put the sign. So 1 by F is equal to, we have 30 centimeter. Then this negative and negative, I make it as positive. Both the negatives together, it is positive. 1 by 15. You already we calculated and got it as 15. Now just cross multiply 15 into 30 by 15 into 30. I think you all know how to do the calculation. We'll get 40 by 450, that is 1 by 10. 1 by F is 1 by 10. So F is equal to 10 centimeter. Next question number 2. A concave lens So I just draw a concave lens. So for a concave lens, only one possibility, object and image will be on the same side, and image will be between object and the lens. That is a constant phenomenon. So keep in mind when you are drawing your diagram. Okay. A concave lens forms an image of an object kept at a distance 20 cm in front of it, at a distance 10 cm on the side of the object. So distance between the object and the lens, and image and the lens is given. This is the object and this is the object and this is the image. Okay, object and image. You are asked to calculate the focal length. What is the nature of the image? First we have to find the nature of the image and calculate the focal length. Before calculating the focal length, it is clear. For a concave mirror, the nature is, we have only one nature, that is, it will be virtual, erect and diminished. So don't want to go to the numerical side. Directly we can write the nature. It will be virtual, erect and diminished. Now we are asked to calculate the focal length. Focal length. Formula for focal length is 1 by f is equal to 1 by v minus 1 by u. Here you can see we have v and u. Distance between object and the lens, that is u, and image and the lens is v. So here you can see all the measurements are to the LHS side. But all things are in front of the lens is taken always negative. Okay, so here u will be negative, v will be also negative. So 1 by f, and for a concave lens, focus is always negative, that is fixed. Convex positive, concave negative, focus. So focus is negative, v is negative, u is negative. Just substitute the values. 1 by negative f is equal to 1 by negative 10. Here negative of negative, I write here positive, 1 by 20. Now just cross multiply. 20 into 120 plus 1 into negative 10, negative 10 by negative 10 into 20, negative 200. 20 plus negative 10, that is positive 10 by negative 200. 0, 0 get cancelled. So we will get 1 by negative f is equal to 1 by negative 20. Both negative will be cancelled. So we will get 1 by f is equal to 1 by 20. F is equal to 20 centimeter. Since we are calculating focal length, we will get the value, magnitude is 20 centimeter, but we know for a focus of a concave lens is fixed, it is negative. So in the bracket you have to write negative, not as a negative sign, as a bracket you have to write negative. Next, question number 3. The focal length of a convex lens. So I draw here a convex lens is 25 centimeter. So focal length is given 25 centimeter. At what distance from the optical center of the lens an object be placed? So you are asked to calculate the distance between object and the lens, that is u. U is equal to question mark, focus is given, to obtain a virtual image. So we just want to write virtual image because that is a hint to do the problem. To form a virtual image of twice the size. Twice the size means how much it magnified. So twice the size means the physical quantity given here is magnitude. So magnitude twice means 2. So we can write m is equal to 2. We are asked to calculate u. We don't have v, u, anything. Object height, image height, we don't have anything. So we have to do in another method. That is magnification. We have the formula for magnification. M is equal to V by U. And for a convex lens, as focal length, magnification is always positive for a convex lens. It is fixed. Okay. Magnification and focus of a convex lens is positive. So magnification positive. V and U. V, here it is given, it is a virtual image. Virtual image means we will get the image on the same side. We will get an erect enlarged image on the same side. So object anyhow it is fixed. Object will be always in the first side, left hand side. Since it is a virtual image, image also will be this side, first side. in front of the mirror. So object and image in front of the mirror means u and v is negative. So we will write negative v by negative u. Since you know negative and negative will get cancelled, we will get v by u. So magnification we already got it as 2. 2 is equal to v by u. Just cross multiply, we will get v is equal to 2u. Just let it be there, we are going to substitute. So we got instead of v, we have to substitute 2u. Now coming to the lens formula, 1 by f is equal to 1 by v minus 1 by u. As I already told, focus of a convex lens is positive. And v and u both in front of the lens taken negative because v is virtual. Virtual image will form only in front of the lens. Here negative and negative will cancel, it will become positive. Focal length is already given. 1 by 25 equals 1 by negative v. V is 2u. So instead we will write negative 2u plus negative of negative positive plus 1 by u. Now we are going to equate, cross multiply u into 1, u plus negative 2u into 1. So u plus negative u 2u by negative 2u square. Negative 2u square. U plus negative 2u. It will become negative u by negative 2u square. Negative negative will become positive. U and u square, 1u will get cancelled. Finally we will get 1 by 2u. That is 1 by 25 equals 1 by 2u. That means just cross multiply, 2u is equal to 25. Just cross multiply, 2u is equal to 25. So from here u is equal to 25 by 2. That means 12.5. Okay, just calculate, divide 25 by 2, you will get 12.5. The final answer we got as 12.5 centimeter. Now I think all your confusions are cleared for doing the numericals. If you have any more further confusion, you please see the video, that the rules. In the first portion, you again watch the video, then you will get a clarity. Or else you just keep in mind, above positive, below negative. In front of the lens, negative. Behind the lens, positive. And you have to keep in mind, virtual images will always form in front of the lens. Real images will be in the opposite side, behind the mirror. And virtual image, in a convex lens, we will have only one option for virtual image. When the object is between f and p, we will get the virtual image. And for a concave lens, only virtual image. Okay, I think all of you understand. Thank you for watching the video.